LOD2, Creating Knowledge Out of Interlinked Data. Welcome to the LOD2 webinar series, Linked Open Data Tools and Services for Publishers, Enterprises and Governmental Institutions. LOD2 is a large-scale integrating project co-funded by the European Commission within the FP7 Information and Communication Technologies Work Programme. This 4-year project comprises leading linked open data technology researchers, companies and service providers. Coming from across 12 countries, the partners are coordinated by the Agile Knowledge Engineering and Semantic Web Research Group at the University of Leipzig, Germany. LOD2 will integrate and syndicate linked data with existing large-scale applications. The project shows the benefits in the scenarios of media and publishing, corporate data intranets and e-government. Once per month, the LOD2 webinar series offer a free webinar about tools and services along the linked open data lifecycle. Stay with us and learn more about acquisition, editing, composing, connected applications, and finally, publishing linked open data.
Thank you, Martin, and thank you to the LOD2 consortium for the invitation to speak. I will start talking a little bit about myself and about the DBpedia Spotlight team. This is more than just my project. There are a lot of people that are key to maintaining this project. I will mention how DBpedia Spotlight fits within the LOD2 stack and the linked data life cycle. Talk a little bit about how we created DBpedia Spotlight. I'll try to give you an overview without going into too many technical details that will potentially not interest everybody, but I'm open for more technical questions later if you would like that. And I will show a demonstration of DBpedia Spotlight before I talk about some lessons learned and the next steps for this project. So I was from 2010 to 2012. I was participating in the LOD2 project. DBpedia Spotlight was started in this context while I was at the Free University of Berlin. I am now at the Open Knowledge Foundation Germany, and I'm helping to lead the development of DBpedia Spotlight with Max Jakob and Joachim Daiber. And other contributors have been helping us tremendously in keeping the development of this tool going forward. For example, Sandro, Chris, Dirk, you, who we call Hector, Marcus, and many others. And we have also helped, we have also received funding from LOD2 DICO, Google Summer of Code 2012, IKS. And we have been generously hosted by the University of Mannheim, the Hungarian Academy of Sciences, the MTA Staki, Globo.com, and the Brazilian Network for Research. So many thanks for all these to all these people. As you know, probably from other webinars or from the LOD2 project, we are talking about in this project about many stages in the development and maintenance of data. So from the extraction of the data to how you store this data, curate or do revisions, how do you interlink the data with other sources, how do you classify and enrich this data, do quality analysis, repair potential problems in this data, enable applications that will search, browse, and explore, and insert the results back into the cycle to improve the extraction and storage and so on. DBpedia Spotlight is a tool that would fit mostly in the extraction step, although it can also support some of the other life cycle stages. We will focus on the extraction today. So DBpedia Spotlight, our tagline is shedding light on the web of documents. Because we're trying to connect text, the documents on the web, to this growing amount of linked data that is being added on the web. And we think that by doing this, we can actually clarify or help understand the meaning in these pages in a better way, as I hope to demonstrate to you in this presentation. The problem that DBpedia Spotlight is addressing, or I guess the core problems, are named entity recognition and disambiguation. So in other words, you can think about putting Wikipedia links into plain text. And so if you think of this paragraph, that Ganglia is a scalable distributed system monitor tool for high-performance computing systems such as clusters and grids, what is the meaning of clusters in the context of this paragraph? Yeah, in this case, we're talking about a computer cluster. And so the first problem that we have is finding that cluster is a concept of interest for us. Okay? And so these strings of interest to us is what we call surface forms. The second problem is then to try to disambiguate or to find the meaning of these surface forms, of these phrases of interest. As you can see in this second paragraph here, the endohedral fullerenes are fullerenes that have additional atoms, ions, or clusters. And in this case, cluster here is not a computer cluster anymore. It's a cluster in the sense of physics. So the disambiguation task is exactly doing that, finding an appropriate identifier that could be a Wikipedia page or a DBpedia URI in our case, that represents an entity. And every surface form can have multiple of these candidate entities. Here we show two potential interpretations of the surface form clusters. So let's look at this sentence for a second. Michael Jackson died in 2007. And let's think about the task of recognition. So the first thing we need to do is look at this sentence and find the surface forms that are mentioned here. So for example, we could mark the starting from Michael ending in Jackson as the surface form that we want to annotate. The second thing we need to do is then to choose the correct entity that is being talked about in this sentence. So for the candidates for Michael Jackson, for example, I'll pick two here, are Michael Jackson, the king of pop, and Michael Jackson, a reporter, a journalist. The context here is that he died in 2007. And if I could ask all of you who was the Michael Jackson, I would bet that many of you were wrongly thinking that this was the king of pop, because that is the most common interpretation of Michael Jackson. But actually, given the context of this sentence, saying that this particular Michael Jackson died in 2007, we can look at the facts, at the data in Wikipedia and in DBpedia, and figure out that this is Michael Jackson, the journalist, not Michael Jackson, the king of pop. Now, if our sentence is instead saying that Michael Jackson came to Paris, this is a much less distinctive context. It informs us much less about the sentences, and it becomes harder for us to disambiguate. And we have to rely on some notion of prominence or default sense of this entity in order to try to make a best guess in this situation. So in order to do this, we have a number of scores that we have been developing over this time that we're running this project to try to correctly identify these entities. And I'm going to talk briefly here about some concepts that are easier to explain, but we have more information in our papers, and I'm also glad to answer questions afterwards. But so one very easy to understand score, I think, is this probability of an entity given a surface form. So given that we know a name, Michael Jackson, who is typically meant by this name, right? So if you look at just the Michael Jackson surface form and ignore the context, what are the probabilities of every one of the candidate interpretations for this phrase, Michael Jackson? And so in this case, let's say probably the singer is much more prominent than the journalist. So this would be represented by a very high score for Michael Jackson, the singer, and a very low score for Michael Jackson, the journalist. And there are other very useful probabilities too. For example, the inverse, the probability of the surface form given the entity, the probability of the entity itself as a prominence measure, the probability of the surface form as an annotation, a probability of annotation measure, and so on. And to compute these scores, what we do is to estimate the maximum likelihood using the Wikipedia as a corpus. So we look at the page links in Wikipedia, and we try to estimate all of these scores. And we have, over the years, created 2 pipelines for performing the data processing and estimate these scores. So one was made to just run in one machine, and it usually runs the whole thing in 6 to 12 hours. And we wrote that in Scala. And later on, we also created a MapReduce style pipeline where we used Apache Pig. And so Apache Pig is a data flow language for analyzing large data sets on top of Hadoop. So instead of, we can just think about querying the data in terms of tuples and bags and maps, can perform filter and join operations over it, group by, store, etc. And Pig will derive automatically a MapReduce plan for us, so we don't have to be writing MapReduce Hadoop Java classes, for example. We created our pipeline on top of something that Olivier Grisel from Apache Istanbul started, called Piganol-Proc. And we have now our own branch, and we're continuing developing on that to compute all of our statistics using this code base. So, for example, back to our probability estimation here of the probability of the entity given the surface form. What we do is just count how many times we see a link in Wikipedia where the surface form Michael Jackson is the anchor text of the link, and the URI for Michael Jackson is the target of that link. And then we divide that by the number of times that we find only Michael Jackson in a link. So using this MLE, the maximum likelihood estimate, we get some insight into if we should think that what we're seeing there is by default the singer or the journalist. We also have many other probabilities, some that are more, many other scores, some that are inspired by information retrieval research. For example, we have created a modification of TF-IDF, which is commonly used for search, and we have created that to try to estimate the similarity of the context of the text with the context of the entities. And we have much material about that on our website if you're interested. So I wanted to show you a little bit our demo interface now. So we have on our website, spotlight.dbpedia.org, we have /demo, we have a demo interface where you can add your text, and you click annotate, and we're going to insert these links to the identifiers in the text. And we offer a series of parameters where you can customize what are your minimum thresholds, so you can control the trade-off between precision and recall. So if you tell DBpedia Spotlight to annotate everything it can, it is more likely to find out most of the tags that you're looking for, but on the way it also makes more mistakes. And if you require higher precision, then it will make less mistakes, but it will also forget to annotate some of the things that you perhaps wanted to annotate. And our objective in developing the tool is to minimize this gap, to make it such a way that we can get as much precision and as much recall, but this trade-off will always be there. And these parameters help you to customize that. I will show this in practice afterwards, but let's go just over an example here. For example, this is a text about LSU, which is Louisiana State University in the US, but it's not really talking about LSU, the university. It's talking about the team from the LSU University, which is the LSU Tigers. So in this case, DBpedia Spotlight did remarkably well by choosing the correct interpretation, although even humans here would potentially make the mistake of thinking that we are talking about the university, right? So when it says LSU picked the wrong time to have its bats to go stone cold and anemic, it's talking about the team, the baseball team, that is not doing so well. Not the university. The university is doing fine. But on the way, and trying to determine very specific senses for the tags that you see there, it also made a clearly really bad mistake by looking at number 4 when it says this team began the NCAA tournament as a lowly number 4. It's talking about the rank of this team. And DBpedia Spotlight went ahead and believed that this was probably an album from a band, which is clearly wrong. So these are this shows how difficult this problem can be, and and we've been working hard to try to remove these mistakes and keep the very interesting disambiguations. So just to show you a little bit here, the score. So the DBpedia Spotlight, besides annotating all of the mentions that you see there, has the option to show you all of the candidates for each one of those entities. So for example, if you have your own strategy for disambiguation, or if you have different needs, then you can plug your application on top of DBpedia Spotlight, ask DBpedia Spotlight to get you the candidates, and then add your own knowledge on top of this to try to fix mistakes, remove things that are not interesting, and so on. And what we're showing here in this top K candidates is that LSU can mean many things. For example, LSU Tigers, the team, Louisiana State University, the school, La Sierra University, another school, and so on, and even Lambda Sigma Epsilon, which is probably a social organization of students in the US, so a fraternity or sorority. And the scores here show that both Louisiana State University and LSU Tigers are very close to the context of this paragraph, of what this paragraph is describing, while La Sierra University is a bit farther off. So throwing away all of the other ones would be easy, but deciding between LSU Tigers and LSU the university is a harder job. Fortunately, in this case, we seem to have done well. So if you would like to try it out for yourself, we have the demo in spotlight.dbpedia.org/demo. And we also have a web service, like I said, for you that want to plug your own solution to leverage what DBpedia Spotlight already does and customize it to your needs. All our source code is available online, and it's licensed as Apache v2, so it's non-viral. You can plug it to your software, and it's not going to require that you also open source your software. There are parts of the code that rely on LinkPipe and GNU, but these parts can be separated, and you can only use the Apache v2. So I wanted to talk a little bit about the APIs that we have to show it to you in practice. So we broke down this problem of recognizing and disambiguating entities, and we provide separate APIs for each one of the steps. So that first step of phrase spotting or phrase recognition can be called through our API /spot. While if you have your own recognition methods and you only want to use DBpedia Spotlight's disambiguation code, then you can just call the /disambiguation API. And the /annotation does both phrase recognition and disambiguation. And the top K disambiguations, the /candidates, returns you all of the candidates already ranked by the scores according to what DBpedia Spotlight thinks is the correct ones. So I will switch screens and hope that it will work here correctly. But so what I'm showing here is, so raise your hand if you can't see my notepad. But there is a function to raise a hand in the meeting. But what we have here is a command line that calls our API /annotate and asks for a return in XML format, gives it a text about President Obama, and sets some parameters, confidence and support. And when you run this on the command line, you get a response in XML pointing to many DBpedia resources that are being mentioned in this paragraph. The same can be done also for RDF, where we use the NIF, the NLP interchange format. And here you can see it in turtle format. And so you can put it in a SPARQL endpoint and query as you wish. Now I want to switch to the web interface. Where I want to show you a little bit about what you can do with the parameters. So I can run an annotation here of this standard paragraph that's talking about President Obama, that on Monday will call for minimum tax rate, and so on. And it has 1 million President Obama taxpayers and officials annotated. But if I increase the confidence, it starts removing the concepts that we're not so confident about. So it's pretty sure about Barack Obama here and about the concept of percentage, but not so much about individuals or earnings. And the same can be done just with the support, which means you can limit your annotations to only prominent entities, that is, entities that appeared many, many times in Wikipedia. And you can also do the filtering based on types. You can request that only people are shown, only organizations are shown, and so on. So to get back to my presentation. So a few lessons that we learned when we started this project. We were super ambitious in wanting to annotate everything in DBpedia, and we still keep that as our goal. But we now realize how hard that actually is. So having 3.5 million things, or 3.7 now, 3.7 million things to annotate of 380 different types, it's not an easy task. So most of the research that we have been seeing focuses on very specialized cases. So they focus on people, location, and organizations, some more common entity types, or they focus on some specific kinds of text, and keeping the tool generic so that you can have any entity types and any types of input text to annotate is quite a hard task. On the other hand, still, the users usually expect that the tool will just work, so they want to put text there and get perfect annotation. And many people don't realize how difficult this can be. So our strategy has been to focus on a generic core that you can use with any entity types and any types of text, and try to make that as easy as possible to customize for specific use cases, so they can use DBpedia Spotlight as a building block in your application. And since we are open source Apache licensed, you should be able to get this and bring it into your home server, your enterprise, and run it. So for our next steps, we are performing more experiments with DBpedia Spotlight. In the context of LOD2, we have started to look into the legal domain in German language with Voltus Klure and emergency response scenario. And we hope that soon we can automate more of the build process so that every time we have a new release in our GitHub, it's already automatically pushed to the LOD stack. At the moment, we have to do that manually. We are continuously expanding to other languages, so we already have produced some demos courtesy of Joe Daber in German language and Dutch language. We're working also on a Portuguese language demonstration and a Hungarian language demonstration. So all these things will be coming up in the next weeks. And we are working on making it easier to adapt the tool to other knowledge bases beyond DBpedia. So this is mostly a practical, technical issue that in the beginning we just assumed one knowledge base, and now we want to make it easier to go to any other knowledge base without having to touch the code. And we are constantly working on new algorithms, including algorithms for collective disambiguation and other algorithms for phrase recognition and so on. So with this, I wanted again to thank everybody for your time and attention. Thanks for the invitation for this webinar, and I'm open for any questions that you might have.
Thank you very much, Pablo. That was really great and interesting, and I think you're working on very, very hot stuff at the moment. So sorry, in my background, there's a phone ringing. I have to stop that. Yes, we're going to the Q&A session. Sorry for the short break. Questions are coming in more and more, so maybe we start with one of these here. So we've got enough time to have a couple of questions. The first one is, how does this relate to the Google Knowledge Graph?
That's a good question. So there has been a lot of talk these days about these knowledge graphs. So Microsoft seems to have its Satori graph, I think that's the name, and Walmart has a social genome, and so every major Yahoo has the Web of Objects, and every major company has to be seems to be investing now on this structured data, and the linking open data project, and now the LOD2 have been talking about these graphs on the web for a while now. So in the practical sense, so since we're based on DBpedia, and DBpedia has links to Freebase, you could consider that DBpedia Spotlight can actually annotate documents with links to the Google Knowledge Graph, because the Google Knowledge Graph contains Freebase. And interestingly, somebody posted a way that you could get into their hashing mechanism and find out how to go from Freebase IDs to Google Knowledge Graph IDs. So DBpedia Spotlight is actually creating some links on the web to documents, from documents to the Google Knowledge Graph through DBpedia and Freebase.
Okay, thank you very much. I think that answers that question very well. There's another one coming in that is saying, can DBpedia Spotlight also annotate XML documents or only text?
DBpedia Spotlight focuses on text, but if you have textual elements in the XML documents, this can also be used. If you have shorter elements that are just, for example, names of people and so on in XML documents, there is, of course, a way to just treat all of them as keywords, so all of the names and things associated to certain elements of your XML can be used. So the quick answer is we don't have that functionality built in, but I can imagine many ways in which you could make small wrappers so that you would enable this functionality with DBpedia Spotlight. And then with the information that you generate from DBpedia Spotlight, you could then connect with other tools in the LOD2 stack, for example, Silk for identity resolution and other tools, so that you can perform, for example, the connection of two entities in knowledge bases. So not only XML, but also relational databases, any other kind of input format that has a little bit of text elements in it. All of these things can be used. You can use the DBpedia Spotlight for them, but the focus of the DBpedia Spotlight is natural language text, as in, you know, paragraphs in a news article or a blog post or product description page and so on.
Yeah, so more on the focus on unstructured text then.
Exactly.
Yeah, that's great. That's interesting. Okay, we got the next one. That's a basic question, so maybe you have an answer on it. It says, isn't annotation different from Wikification?
My answer to that would be, so Wikification for me is a specific kind of annotation. So in Wikification, you're adding links in a wiki to a wiki. And if you think about Wikipedia Wikification, then there's also some guidelines that should be followed. So for example, you only annotate the first mention of each concept in a document, and you do not annotate obvious concepts. So if you're saying that the president had a dinner with another president from another country and they ate garlic, you should not annotate garlic because garlic is a common sense thing in Wikipedia. However, in annotation, I could think of use cases where annotating garlic could be interesting. So give me all things that the president has eaten in the past year, right? Or, you know, some more serious use cases than just this easy example. But I would say Wikification is a particular style of annotation, and there are many others from the use cases that we have looked into. So we use annotation as sort of an umbrella term for all these specific ways to annotate.
I think that clarifies that question also very well. Thank you very much. So there is one question that is also one for me, as we discussed in the forefront. It's about disambiguation. It's a question how deep we can dig into it, but the question is, can you explain again how to estimate the probabilities for disambiguation from the DBpedia corpus, please?
Well, it's actually done in the Wikipedia corpus, so we're not looking here at a collection of triples per se. We're looking at a collection of paragraphs. So we go over all of the text in Wikipedia that mentions DBpedia concept. So what do I mean by a paragraph mentions the DBpedia concept? It has a link to the Wikipedia page that describes this DBpedia concept, right? So we're basically looking at all the wiki links, all the Wikipedia links in the Wikipedia corpus. And from these wiki links, we're counting how many times a specific surface form appears with a specific URI to estimate the probabilities. So I don't know if he wants me to go in detail back to the slide again, or if this answers the question.
I think as I see who is asking, I can bring you in touch afterwards because I know the person who was asking. So I think for the moment it's okay because we got really plenty of questions coming in. And it's good that we have a little bit time left. So I think for the time being that was a good answer, and maybe otherwise that's in principle a point. I think, Pablo, if people would like to dig deeper and get in touch with you, then we got your contact details, and I think
yeah, it would be a pleasure to talk about this.
All right,
yeah.
That's great. So we have one here that is saying, can you use DBpedia Spotlight with OpenRefine?
The answer to any question when you say can, I will probably say yes, because it only depends on somebody sitting down and coding it. But I think what you're saying here is if we have a wrapper to DBpedia Spotlight in the LOD stack so that you can quickly plug OpenRefine to it and use. So this wrapper is not there yet, but I can see how one could just easily create a wrapper that speaks the OpenRefine API, so that you can get your CSVs or whatever and ask the DBpedia Spotlight for candidate disambiguations based on the context, and I can see how that could work very well. But no, we don't have that interface created yet.
Maybe coming up in LOD2, but I don't know neither, to be honest, at the moment. Okay, there's another one saying, a nice thing, we had a pleasure to use DBpedia Spotlight, but we had been pointed to AIDA. Could you comment on the differences, similarities of these two, the AIDA and DBpedia Spotlight?
Yes, there are many differences, and there are also many other tools. So I know AIDA, they're doing great work over in Saarbrücken. I know Johannes, so they, I don't know what are the newest developments that they have now, but from what I was following, they were mostly focusing on people, location, organizations, and the DBpedia Spotlight does all kinds of concepts. They have already a form of collective joint disambiguation, while the DBpedia Spotlight has not yet released the things that we're working on in that sense. So in some use cases, they could benefit from this, but it has also been discussed in literature that collective disambiguation can skew disambiguation in the wrong direction in some cases. So I think the best way is to try it out for your use case. So you need to see what exactly you want to annotate and see which tool fits you best. So yeah, I would be glad to help conduct this experiment, because benchmarking is a very important activity for us as well. So yes, it's a good tool also, and we should test and compare them as much as we can.
Absolutely. Something like an annotation benchmark would be good in this area. Okay. Another one coming in. So we have a little bit of time left. What other sources, especially German ones, do you have in mind beside DBpedia? What are preconditions for these sources?
Of course, clearly there is the corpus that LOD2 and LOD2 are working with of legal documents that could be very informative in that domain. So basically any kind of examples of documents that mention the entities that you want to annotate can be fed into the system as a way to build context for disambiguation. So things that I have thought about are, for example, the laws and all the legal information that LOD2 has, but also it could be books or other articles. If you're thinking about, for example, annotating German, I don't know, health documents, you would have to look for health for examples of health articles, so that we could feed that into the system too. But basically, you know, whatever source of text you have, if you can convert that into CSV file saying that column 1 is the concept, is the DBpedia URI, column 2 is the text, where this URI appears. If you give that to the DBpedia Spotlight, we can learn something from it. So.
Okay, I think that also answers a little bit another question that came in that says, can we configure another knowledge database except DBpedia and Wikipedia for annotation? So that's clearly not.
Yes, it's possible. There are some technical things. So in the current knowledge base, so we're working on modifying our source code so that we don't have the DBpedia namespace just assume that this is going to be always our namespace. So there are small fixes that we have to do it in a few points of the code to make it generic to use to other knowledge bases. But like I said, if you have a text file with URIs and examples of paragraphs that mention these URIs, we can do something with it. It's just a matter of the code maturing a little bit over the next week so that this can be done without you touching the code to fix it. But we've had people already adapting to the Portuguese and Italian and German and Dutch DBpedias, which requires us to touch the source code and change the URIs, but in the future we want this to make it even easier. So it is possible, and it will become even easier to do in the future.
Okay, great, because there are two related questions. The one that really just in the moment you mentioned Italian language was coming in is or will it be possible to use Spotlight with Italian language? So you're working on that, as far as I understood?
Yeah, it's work in progress.
That's great. And the second one is a little bit similar, but maybe a few words from your side. Is it possible to annotate text based on an internal company RDF store instead of DBpedia? Then it should also be possible.
Yeah, it's a similar answer. Yes, it's possible. It needs a little bit of code to reformat things a little bit, but yes, it's possible.
That's great. So, and another one in the same direction. So, really, a lot of questions. What is nice is saying, is it possible to use DBpedia Spotlight to annotate records in a structured database? For example, a library catalog where you do not have as much textual context, but the field in which the data occurs gives context or more info. So in more structured databases, repositories.
Yes, readily you can do that by looking at the records as tags. So it's some sort of non-structured text. So we can do that readily out of the box. But there are other smarter things that you can do by looking at the fields separately. This is something that it's been in the back of my mind for a long time. I have not sat down to implement yet. But whoever asked this question, if they want to get in touch and run an experiment with us, that would be very exciting to do. Maybe I should point out here that there's a tool in the LOD stack. There are maybe two tools in the LOD stack that do exactly this, to connect records in structured databases, Silk and Limes. These two tools could potentially be combined with DBpedia Spotlight to help in this task of annotating records in a structured database. Or you could just build on DBpedia Spotlight and do your own record linkage solution. So both things are possible.
I'll say, sounds great. Thank you very much. So I have one last. So we have, I think, 20 minutes now of question and answering. Can you deal with concepts represented by non-adjacent words? For example, information search and retrieval. That goes for information search and information retrieval.
Great question. That's a canned question that I will answer no. So we don't have a spotter that uses the conjunction as a way to kind of infer that information here is actually modifying retrieval, and so we cannot do the non-adjacent words trick. But this might actually work if you put information search and retrieval, because retrieval itself could be an alias for information retrieval. But that would be sort of more of a coincidence than actually a method. So this could work in some cases, but we do not have a specific technique in the DBpedia Spotlight for dealing with non-adjacent words. Yet.
Yet. Okay. I have one more question because it just came in, and I think maybe it's an interesting one. It's saying, do you have any special approaches for working with colloquial text, both recognition and disambiguation? Any details would be very helpful.
We do have for recognition. So one of our phrase recognition approaches does not rely on NLP techniques at all, so we don't need the parse of the sentence. We just tokenize the text, and then we run a substring matching algorithm with a dictionary of known names. So we load all of the names that we know into memory, and then we find these names in the text, and we can then do some sort of fuzzy matching there. So if there's a little misspell, like one letter missing or something like that, we can still catch. So for colloquial text, these are some of the things that are problematic. For example, faulty grammar or misspellings and something like that. So we do have recognizers that can deal with this kind of text. For disambiguation, not so much. I don't think we did anything special for this kind of text besides some experiments we have with the folks at the Wright State University, where they're running analysis of blog posts that mention drug abuse. And in that case, we can use a little bit of the knowledge of the domain to help with the disambiguation there. But besides this domain bias, we're not looking into disambiguation approaches for colloquial text at the moment.
Okay. Would you like to have another one?
Sure.
We have lots of them. Okay, because it's somehow like a little bit the discussion floating through myself. And what about recognition on text from Twitter?
We have run some experiments. So it's complicated because, like colloquial text, it has not perfect grammar and misspelling sometimes on purpose because you have to fit it within 140 characters. And the second problem would then be that 140 characters limits the amount of words they can have around to help out with determining the context. So it is a tough case, but there is work on this, and not promising, but perhaps we might release some results on text from Twitter in the coming weeks as well. Can be done. It's tougher than full documents, but it works reasonably well.
Okay, that sounds very promising. And now I really got the last one, and that is saying, what is the best way to get in contact with you? So what are your contact details? As you see, there are lots of questions.
Yes. You can send emails to pablomendes@gmail.com. I also have my website. If you search for Pablo and Mendes, it's probably, at least for me, is the first hit. I don't know if it's going to be for everybody because Google not has the personalization. But you can also go to my website, pablomendes.com. It's an alias that I have to my current website. And I believe also on the LOD2 website you can find my contact details over there.
Absolutely. So thank you very much. And all participants, if you take a look at the chat of the online room, you now find the website that Pablo mentioned, pablomendes.com, and all the other information. So as time is running, I think we had a really great webinar together. So thank you very much, Pablo.
Thank you for the invitation, and thanks everybody for your great questions. I look forward to getting in touch with many of you.
Yeah, I'm sure that you get a lot of requests and infos and contact requests now after this webinar. Last but not least, I would like to tell everybody that the LOD2 webinar series will continue. So we will have on the 27th of March 2013 a webinar on CCAN and publicdata.eu by the Open Knowledge Foundation. So this will be again at 4 o'clock Central European Time, 4 p.m. And in April, we have a promising one. We will have people from Open Link Software here and from CWI from Amsterdam in the Netherlands. And they will tell us a little bit more about the new release of Virtuoso 7, so the RDF triple store, and some combination with MonetDB that was brought in by CWI and the LOD2 project. So thank you very much for joining. And Pablo, thank you very much for that great webinar. And all of you have a great afternoon. So bye-bye.
Bye.
Hope you enjoyed staying with us. If you need more detailed information, visit us at www.lod2.eu and let us know how we can improve to meet your expectations. Don't forget to register for our next webinar. Have a great day and don't forget.